Good morning, class. Today we're going over lesson 1.6, how to use the properties of integer exponents. So basically we're going to be talking about different rules that are invoked when we have exponents. And remember, an exponent is just any number for example, if this is just my base here, an exponent is the little number that goes above it in the corner here. So for example, when we were working with squared numbers, if let's say we're working with 2 squared, this right here is my base, and this is my exponent. Same with cubic numbers, right? If we're talking about like 3 cubed, this is my base, and this is my exponent. Now, this is something we learned in the past here. We should have learned it in 6th grade. However, we can do a little bit of review here. I want to just review what writing exponents in expanded form is. So let's say we're looking at something like 2 to the 5th power. So right again, this right here is our base, and this is our exponent. So what this is telling us this is equal to here, it's not 2 times 5, it's 2 times itself 5 times. Just like when we were working with a cube number, it's that number times itself 3 times. So with 2 to the 5th here, we could rewrite this as 2 times 2 times 2 times 2 times 2. Because we would be multiplying the base, which is 2, times itself 5 times. Because our exponent here is 5. Let's try a different one. What if we wanted to do 10 to the 4th? Well, we could rewrite this here as our base, which is 10. So we have 10 times itself 4 times because our exponent is 4. So again, the base or the large number, it was what implies what we're multiplying, and the exponent implies how many times we're going to multiply it. So one last one here. Let's say I want to do 5 to the, to the second. Then we would do 5 times 5 2 times, just like 5 squared, again, because to the power of 2 is the same as 5 squared. So that's just a quick little review of us of how we do our exponents. Remember, it's just that number times itself, however many times that exponent is there. Okay, so let's start off with some definitions. We have a lot of definitions today, so you're going to want to make sure you're probably pausing the video to get these down here. So our first one is the product of powers property. So when multiplying 2 powers with the same base, you can add the exponent. So when multiplying 2 powers with the same base, you can add the exponent. So right here in this example, we see we have two numbers here, right? We have the same base here. The base is 2 for both of them. So what we could do is we could take the exponents from both of these numbers here, and we could add them together. So 2 to the 3rd times 2 to the 6th would be 2 to the 3 plus 6, which is equal to 2 to the 9th, because 3 plus 6 is 9. The reason this is because we could rewrite 2 to the 3rd 3 times, plus 2 to the 6th we could write 6 times. And then if we count up how many numbers we have here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers here, 9 2s. So again, when we're multiplying a 2 by itself 9 times, we could rewrite that as 2 to the 9th. Or we could use our product of powers property to take a little shortcut here and just simply add the exponents as opposed to rewriting it in its expanded form. Okay, the next one we have here is the power of products property. So it's a little bit kind of like the opposite here. Instead of product of powers, this is the power of products. So when multiplying 2 exponential expressions with the same exponent in different bases, you can multiply the bases and keep the exponent the same. So for 2 to the 3rd times 2 to the 12th, if we rewrite this here, we could rewrite it as 2 times 2 times 2. That's where from the 2/3. And we could rewrite the 12 to the 3rd as 12 times 12 times 12. So if we rearrange this here using our associative property, we can take each 2 and 12 and pair them up together. So like these 2 would go here, these 2 would go here, and these 2 would go here. So we have 2 times 12, 2 times 12, 2 times 12. So in the middle here, we could just multiply these 2 together because we have 2 times 12 3 times. So 2 times 12 to the 3rd. And if we actually do the math, 2 times 12 is 24. So this becomes 24 to the 3rd. Or you could simply use your power of products property to skip to the last step there and just do 2 times 12 with the same exponent. We have to keep our exponent the same in this one here. And 2 times 12 is 24. So you get a 24 to the third. Okay, next one here, we have the power of power property. So this states that to find the power of a power, you simply have to multiply the exponents. So what this is when we have an exponent written like, let's say, 7 to the second. Oops, maybe I should rewrite it like this. Let's say we have 7 to the second, and then in the parentheses outside of it here, we have to the third. So we have a base with a power. This is our base. This is our power or our exponent. And then we are again raising that to another power, or we have another exponent there. So it involves a number that is going to an exponential power being raised to another exponential power. So what we have to do here is we have to multiply the two exponents together. So this would become 7 to the 2 times 3, which is equal to 7 to the 6th. Similarly, over here in this example, we have 5 squared to the 4th. That's the same as doing 5 squared times 5 squared times 5 squared times 5 squared. Using our product of powers property, we could just add these all together. So we can do 2 plus 2 plus 2 plus 2, which is equal to 5 to the 8th. Or you could just skip to the last step here where you multiply these two together, and you would have gotten 4 times 2 is 8 using the power of power product. Or excuse me, power of power property. It's a little alliteration there. Okay, last one here, we have the quotient of power property. So in dividing two exponential expressions with the same base, we simply have to subtract the exponents. So the example we are given here is 6 to the 5th divided by 6 to the 3rd. We could rewrite this as a fraction. That's the first thing you're going to want to do. You're going to want to put the top number, or the first number on top and the second number on bottom. So 6 to the 5th over 6 to the 3rd. Notice how you have 1, 2, 3, 4, 5 6s on top and 1, 2, 3 6s on bottom. If we notice here, 3 of the 6s on the top and bottom will cancel out. So all that we are left with is 6 times 6, or 6 squared. Now we could have also solved this one here from just subtracting from the get-go. So if we would have noticed on this step here that we could invoke our quotient of powers property, we could have done 6 to the 5th divided by 6 to the 3rd. 5 minus 3 is 2, so you'd be left with 6 squared. Let's try one out for ourselves here. Let's do 10 to the 12th divided by 10 to the 8th. As we did over here, let's make this as a fraction. So let's do 10 to the 12th over 10 to the 8th. We simply need to subtract our exponents. So we're going to do 10 to the 12th minus 8, which would be equal to 10 to the 4th. And again, we can rewrite this as we want, but we know it's correct because we have used our quotient of powers property. Okay, so for our key concept today, when working with exponents, we can use these properties to help us simplify expressions with exponents. Real quickly, I restated all of our different properties here, whether it's the product of powers, the power of products, the power of a power, or the quotient of powers property. They all tell us, the product of powers, the power of powers, and the quotient of powers all tell us that when the bases are the same, those three have bases the same, you either add, multiply, or subtract the exponents. However, the power of products property tells us that when our bases are different, you multiply the bases together and keep the exponents the same. So this one right here is probably the one we're going to use the least because it requires the most specific condition, I'll say. You need to have different bases but same exponents, which can be rare. Whereas the other ones require the same bases. We'll be using those much more often. Okay, so let's start with an example here. We have 2 to the 8th times 2 to the 4th. So we got to ask ourselves here, what property should we be using? Is this the product of powers or is this a power of products? Let's double check back here. So we have same bases and different exponents, right? So that tells me that we're going to be using the product of powers property, this one right here. Okay, so remember, this one tells us that when we have the same base and different exponents, we need to add the exponents. So I can rewrite this here as 2 to the 8th plus 4. 8 plus 4 is 12, so this would become 2 to the 12th. See, simple as that. We saw we have the same base and different exponents, so we just need to add the exponents when we are multiplying. Okay, next one here, 8 to the 7th over 8 to the 3rd. Well, again, we have the same base here. It's both 8, right? Our exponents are different. However, since we have this as a fraction, that's our number one indicator that we are going to be using the quotient of powers property. So again, that tells us we are going to keep our base the same. It's going to stay 8, and we are going to subtract our exponents. 7 minus 3 is 4, so this would become 8 to the 4th, because you have to subtract your exponents there. All right, 2 more for us here. All right, so we have a number in parentheses to an exponential power, and then that to a power again. This right here is an indication that we are going to need to use our power of power property. So what that tells us is we keep our base the same, and we multiply our powers. So we have 3 to the 4 times 5. 4 times 5 rather is 20. So we have 3 to the 20th, which would be our answer here. And again, we use this using our power of power property. Okay, last one. We have 3 to the 9th times 2 to the 9th. Well, we know here is our bases are different, but our exponents are the same. So that means we need to do is we need to go inside our parentheses and multiply and keep the exponents the same. I'm going to double check on this one, right? Yes, we multiply our numbers together and keep the exponents the same. So 3 times 2 is 6. Our exponent stays the same. So 3 to the 9th times 2 to the 9th would become 6 to the 9th. Alrighty, everybody, that's all for us today. Simply what we learned about was our different exponent rules. So make sure you guys are getting that down in your in your conclusion here. You're talking about the differences between the rules and definitely 2 sentences about what you learned tonight. Alrighty, everybody, I'll see you in class tomorrow. Have a great rest of your day. Peace out, everybody.